Example 8. The graph of a parent function f is given. In each case, graph g by applying one or more transformations to f. All right, so if you just give this page a quick scan, you will see that there are 4 different graphs here. Each of the graphs has the same parent function. So remember, if I use that phrase parent function, that is the basic function that you have been given that you need to apply the transformations to. Okay, so in each case, we'll be using the same parent function. We'll just be applying a different transformation in each example. Okay, so let's take a look at example A, part A here. We have our parent function, and the parent function is f. So we are trying to graph a new function g of x, and to get g of x, you're basically graphing f of negative x. Okay, so basically, if you look at this side, okay, that's telling you basically the transformation that you need to apply. Okay, looking at this, the parent function here, it has 4 points emphasized. So the -4, 2, -2, -2, 0, -2, and then 6, 2. All you have to do is basically, when you do the transformation, you have to figure out where those 4 points go, and then the entire graph will move as long as you connect your new dots with the same basic shape. Okay, so in part A here, okay, this is f, this is the graph of f, okay, we're trying to graph f of negative x, okay, so you have to think about what kind of transformation is that. Well, it involves a negative, okay, so since a negative sign is involved, that means it is some sort of reflection, okay, so you may need to flip back to the reflection rules if you haven't, memorized these yet, to figure out what kind of reflection it is. The negative is inside the parentheses. So let's go ahead and flip back to, I think it was page 7, where the reflection rules are. Here they are. If you look at the 3 different scenarios, the one in the middle here, that's where you have a negative sign on the inside. So we need to graph a reflection across the y-axis. Okay, so that's what's going on here. This is going to be a reflection over the y-axis. Okay, so if you remember how to do this, okay, it's basically y-axis symmetry. So if you start with a given point for y-axis symmetry, that means y is going to stay put and you're going to change the sign of the x value. Okay, so I'm going to come over here, and if you can either do it with the thinking of it as folding the sheet of paper along the y-axis and thinking about where the points go. If you need something more structured here, just make a list of old points and new points. Okay, so let's do that here. Okay, so I'm going to write down the 4 points that I see. So like I said, -4, 2, and then -2, -2, and then 0, -2, and then finally 6, 2. So we need to figure out where each of those points ends up if we basically fold our sheet of paper along the y-axis. Okay, so let's start with -4, 2. Okay, so basically what's going to happen, like I said, this is the same thing as y-axis symmetry. To get where this point goes, if you do a reflection over the y-axis, you are going to change the sign of the x-coordinate. So it will become +4. You're going to keep the y value the same. So this point right here is going to get sent to 4, 2. Okay, so that's going to be right here. Okay, another way you can think about this reflection for this point, okay, it is currently 4 units to the left of the y-axis. So if you fold the sheet of paper along the y-axis, the point's going to get sent 4 units to the right of the y-axis. Okay, whichever way makes more sense to you, do it that way. Okay, all right, next, the point -2, -2. Okay, where does it go if you fold the sheet of paper along the y-axis? Well, we know from y-axis symmetry, that means we're going to change the sign of the x-coordinate, so it'll go from -2 to +2. We will keep the y value exactly the same, so it'll get sent to negative 2. Okay, so the new point is going to be 2, negative 2, and that is going to be right here. Okay, so here we go, like right there. Okay, again, you could have looked at this point and said, hey, it's 2 units to the left of the y-axis, so when I fold the sheet of paper, it's going to go 2 units to the right of the y-axis. Okay, all right, moving on to 0, negative 2. Okay, that's this point right here. Okay, so we need to change the sign of the x coordinate. Okay, so 0 doesn't have a sign associated with it, so it's just going to stay 0. We need to keep the y value the same. So this point actually stays put. That makes sense because it's on the y-axis. So if we fold our sheet of paper along the y-axis, that point won't go anywhere. All right, the last point, 6, 2, this guy, where does it go? We need to change the sign of the x coordinate, keep the y value the same. So it is headed to negative 6, 2, which is right here. Okay, again, you could have looked at this point right here at 6, 2. It is 6 units to the right of the y-axis. So if you fold the sheet of paper, it's going to get sent 6 units to the left of the y-axis. Okay, so our 4 points have moved. We just need to connect them with the same basic shape. You're basically going to go from left to right, and you're going to connect each pair of points with a line segment. Okay, so if I start here, I'm going to connect these 2 dots like that, and then I'm going to connect the next pair like this. And then finally, I will connect these 2 points. And there we go. We're done. Okay, so we have taken the original parent function that's in black and we graphed the reflection over the y-axis. All right, moving on to part B. Okay, again, we've got the same parent function. We just need to graph a new set of transformations here. Okay, so this is f, so now we're trying to graph negative f of x minus 4. Okay, so there's a couple of transformations going on here. Okay, because you see a negative sign out front and you see minus 4 inside the parentheses. Okay, so there's 2 transformations. We do need to stick to the order of operations as far as which order we do them in. So remember, order of operations, please excuse my dear Aunt Sally, you always want to do what's in parentheses first. So we're first going to do the parentheses and then we will handle the negative sign out front. Okay, so let's talk about what this negative sign, or sorry, what this x minus 4 in parentheses means. Okay, so x minus 4 in the parentheses, since we are adding or subtracting, we're actually subtracting inside parentheses. That is a horizontal shift. Okay, so we learned one of the first transformations we learned was how to move left or right. If you are subtracting inside the parentheses, that means you're going to the right. Okay, by this many units. So we're going to have to move each point right 4 units. Okay, and then once we do that, that will give us a new graph. Okay, and then we have to apply the negative out front. Again, you've got a negative sign that involves some kind of reflection. So if you go back to page 7, look at the first rule. If the negative is out front, that's a reflection across the x-axis. Okay, so your second transformation here will be to reflect over the x-axis. Okay, so let's do this. Okay, it's up to you if you want to do both transformations at once, or if you just want to, make a graph by applying the first transformation, and then once you have that graph, apply the second transformation to it. That's up to you. Okay, this is what I'm going to do. Okay, so I'm going to keep this in blue. Okay, I'm going to move each point right 4 units. Okay, so if I start with the point negative 4, 2, I'm going to move it right 4 units. So 1, 2, 3, 4. Okay, it's going to get sent right here. That is the point 0, 2. Okay, I'm putting an X here instead of a dot. I know that I'm going to have to come back and do the reflection over the x-axis. It's not going to be a final point, so I'm just putting an X there. Okay, so I'm going to come back and reflect all the x's. Okay, all right, the next point, negative 2, negative 2. I need to move it right 4 units. 1, 2, 3, 4. Okay, so it's going to get sent right here to 2, -2. Okay, the point at 0, -2. I need to move it 4 units to the right. 1, 2, 3, 4. It's going to 4, -2. And then lastly, the point that's at 6, 2, it needs to move over 4 units. So 1, 2, 3, 4, it's going to go to 10, 2. Okay, so we've done the shift right 4 units. Okay, those are the x's. Okay, so now we need to take each x and reflect it over the we need to take each x and reflect it over the x-axis. Okay, and then that will be a final point on the graph. Okay, so let's start with this first x. It is at 0, 2. Okay, imagine you're folding your sheet of paper over the x-axis. Okay, where does it go? It's 2 units above the x-axis, so it's going to get sent 2 units below the x-axis. Okay, so this point will end up here. All right, the next x, it is located at 2, -2. Okay, it is 2 units below the x-axis. So when you fold the sheet of paper, this point's going to go above the x-axis by 2 units. Okay, so it will end up at 2, 2. Okay, I'm actually going to, let me go ahead and notate these points. So this point was 0, -2. This point's going to be 2, 2. If we go to the third x, it's at 4, -2. Okay, it is 2 units below the x-axis. If you fold the sheet of paper, it's going to go 2 units above. So this point will end up at 4, 2. And then the last x, that's at 10, 2. It is 2 units above the x-axis. So if you fold your sheet of paper along the x-axis, it is going to go 2 units below the x-axis. So it will end up at 10, -2. Okay, so your 4 points have moved. You just want to connect them, go from left to right and connect each pair of dots chronologically. Okay, so we're going to connect these 2 points, and then we're going to connect these guys right here. And then lastly, we'll connect these 2 guys. So we end up with this red graph as our final graph. Okay, so basically this is what the black graph looks like if it is first shifted right 4 units and then it's reflected over the x-axis.